historically, about 1 out of every 5 of you will end up working in the power industry, and you'll be working with three-phase power exclusively. So in order to understand what three-phase power is, we have to first talk about what we've worked with so far, which is single-phase power. So single-phase power is what we get in residential buildings with outlets that are less than 30 amps. And that's the standard kind of outlet that you see all over the place. That looks like that happy face. And it's got 3 wires in it. It's got a hot wire, a neutral wire, and a ground wire. The hot wire carries your power. And if we were to describe it in terms of a phasor, it would be 120 volts RMS. Sometimes they call it 110 volts RMS too. Either one. Both the neutral and the ground are both 0 volts RMS. Sometimes you'll hear the ground wire being called earth. Anyone work with electricity and power companies? Wiring houses? Does anyone know what the colors of these wires are?
Black, red, and white, or black, white, and red.
Yep, it's almost. Black, white, and ground is
Green.
Green. We'll get to the reds in a moment. So the black wire is this one, the white wire is that, and the green wire is this one. Now, you know you only need 2 wires to carry power. And these are the 2 wires that carry power in a residential settings. In general, there should be no power at all flowing through your ground. The reason why we have a ground is only for safety purposes. Let's say you are using a power drill. This is one of those old-fashioned power drills that are made of metal. So it has a metal body. Draw it with a thicker case. So it has 2 wires going into it. It's got your V hot, and it's got your V neutral. So electricity, we think about it as going up through the hot and returning through the neutral. But we know that if the neutral is truly 0 volts, that means that the hot alternates between plus and minus 120 times the square root of 2, or between a maximum and minimum of 167 volts, give or take. And that means the electricity actually flows back and forth in the neutral wire. But our approximation that we think of is that power is flowing in through the hot and out through the neutral. And inside this, there's a resistance. If that's all there is, everything works out great. When power was first introduced to residences, though, they found that it was very common for there to be shorts inside the power line. So if there was a short here, you'd have an infinite amount of current flowing through that wire. The wire would become hot and get on fire, and that's obviously a safety hazard. So when wiring was first introduced to homes, they put a fuse, now a circuit breaker, on the hotline, on every single hotline. So every single electric outlet has got a appropriately sized circuit breaker. For residential lines, they're typically 15 or 20 amps. And if you get the short inside it, it'll pop the circuit breaker. All right, so far you don't need that third line. That third line becomes important because what if there's a short on this neutral line to the body of the tool, and the body of the tool is metal. So someone tell me what happens then.
Would you get electrocuted?
No, because now before the body of the tool, the metal body of the tool was floating. It could be any voltage, it doesn't matter. Now you've tied it to 0 volts. And so now you're holding something that's at 0 volts. So you're not going to get electrocuted. So that's not a problem. But what if instead it's the hot wire that gets attached to the tool? Now what happens?
Now you get electrocuted.
Probably not still, because now though the outside of the tool is 120 volts, that would make you 120 volts, but it's still not flowing anywhere. I mean, unless you were to somehow take your other hand and open up the neutral wire and grasp it. So you're actually still pretty safe. What if though you were standing in a puddle of water, and that puddle of water is not just a puddle of water, but it's a puddle of water on ground. So that was a poorly drawn ground. On ground, so that puddle of water is 0 volts. Now what happens?
You definitely get electrocuted.
Yes, finally you've got power, and it goes through the hot line, through the body of the tool, through your arm, through your feet that's standing in the water, through your puddle, and down to 0. So now you've got actually a voltage potential across your body. Still probably won't get hurt. It turns out that 120 volts, even though this is going right through your heart, still, unless it happens to hit your heart right in the middle of your T interval of your cardiac cycle, it's unlikely to do any harm at all. It's likely just to make your heart squeeze up and stay there. If it hits right during the T cycle, which there's maybe 1 or 2% chance of it happening, that's when something bad could happen. So even though it's highly unlikely to need more protection, we add an extra layer of protection by having this ground wire. And so every outlet has this extra green ground wire. And now if this short happens, you'll get a huge amount of electricity that flows through this hot wire. It might flow through your body, but remember, that's still probably going to be relatively high resistance. Instead, it'll all flow through a current divider relationship, almost all through it'll all flow through this ground wire, and that will trip the circuit breaker, and then nobody gets harmed. So it's unlikely you'd get harmed even without the ground wire, and that's why if you ever have a tool or a device that you need to plug in the wall, and it's got this extra wire at the bottom, and you can't, an extra prong, and you can't get it to fit, you don't have the right outlet, you can probably just take a pair of pliers and pull this green ground connector off and have everything work right. Just realize that you've now just lost that extra layer of protection. If you've got a device that doesn't have a metal casing, though, you probably don't really need that extra layer of protection to begin with. Okay, so this is single phase residential power, and if we were to graph it, it looks like this. Here's our V neutral at 0 volts, and at 120 volts away from it, we have our V hot. And we don't draw our green wire at all because in general it's not used. Okay, so that's the standard single phase power.